Question number 1. If PO vector plus OQ vector is equal to QO vector plus OR vector, show that points PQR are collinear. See, we will be solving this question with the help of triangle law. We have seen that a triangle is there with the points O, P and Q. Then PO vector means this vector, OQ vector means this vector. Now, by triangle law, we can say that since these two sides are representing two consecutive vectors, the sum will be PQ vector. So, we can say that PO vector plus OQ vector, this is equal to PQ vector by triangle law. Similarly, OQ vector plus OQ vector. Now again we make a triangle. Here, this is our point O, this is our point Q, and this is our point R. QO vector means this vector, OR vector means this vector. So sum will be QR vector. So we can write QO vector plus OR vector. This is equal to QR vector by triangle law. Now we can say that we have been given PO vector plus OQ vector as PQ vector, and we can say that OQ vector plus OR vector is QR vector. It means that PQ and QR are either parallel or collinear. So PQ vector and QR vector are either parallel or collinear, because one vector is written in the form of another vector lambda times. So here it is 1 time. So PQ vector and QR vector are either parallel or they are collinear. Now since Q is the point here, which is common point. So they cannot be parallel, rather they are collinear. But we find that Q is a point common to them. So Q vector and QR vector are collinear, because we find that Q is a point which is there in PQ vector also, which is there in QR vector also. So both vectors are collinear. Q is common point. Hence PQR are collinear points. Hence PQR are collinear. That is, they lie on the same line. Now we will see the next question. Now we will see question number 2. If O is the center of a regular hexagon ABCDEF, find the sum of vectors OA plus OB plus OC plus OD plus OE and plus OF. See, first we will make the diagram and then we will see the question. See, here we have been given A, B, C, D, E, F. This is a regular hexagon. Regular hexagon we know is one which has all the sides equal. So, there is a property of regular hexagon that the diagonals bisect each other at center. O is the center, means AD is bisected at point O. Similarly, diagonal BE is bisected at point O. FC diagonal is bisected at O. Means we have here OA and OD vectors which are in opposite direction. So OA is equal to minus of OD. Both are equal in magnitude but opposite in direction. Similarly, OB vector is equal to minus of OE vector. And OC vector is equal to minus of OF vector. Now, with this we can say that OA vector plus OD vector is equal to 0 vector. Similarly, OB vector plus OE vector, this is equal to 0 vector, and OC vector plus OF vector, this is equal to 0 vector. Now we want here the sum of vectors OA, OB, OC, OD, OE and OF. So we can say that OA vector plus OB vector plus OC vector plus OD vector plus OF vector is equal to, we can club 2, means OA we club, OA vector we are clubbing with OD. So OA vector plus OD vector, this we have paired, plus OB vector we have paired with OE vector. So it is OB vector plus OE vector plus OC vector plus OF vector. These will be the pairing up such that OA and OD we can make 0, OB and OE vectors sum we can make 0, and OC vector plus OF vector we can make sum as 0. So this becomes 0 vector plus 0 vector plus 0 vector, which is equal to 0 vector. And hence the required sum of OA vector plus OB vector plus OC vector plus OD vector plus OE vector plus OF vector is 0.